Ladies and gentlemen, we're going to integrate 1 divided by sine theta, and it's going to be awesome because we get this crazy result, although the integral is not that bad. Now, there's a variety of ways to do it, but if you're stuck, you can try a u-substitution, which is what we're doing right here. Now, the most obvious is to set u equal to sine theta, and I did that, and it just didn't really work out that well. It got more complicated, so I tried u equal to cos theta, and it worked out pretty good. So this is what I'm showing you now. So if we set u equal to cos theta, we'll take the derivative and rearrange to get du equals sine theta d theta. And now we'll substitute what d theta is. If we divide both sides by negative sine theta, d theta becomes du divided by negative sine theta. And now it looks like things got more complicated, right? We started with sine theta, and now we have sine squared in the denominator. But we're going to invoke a famous trig identity, one that we all know and love. Sine squared theta plus cos squared theta equals 1. And we have negative sine theta in the denominator, right? Sine squared theta. So if we move this sine squared theta to the right, it becomes negative. And we'll move the 1 to the left. We got cos squared theta minus 1 equals negative sine squared theta. Well, cos theta is u. So if we move this sign over, negative sine squared theta equals u squared minus 1. I hope you see that. Let me know if you see that or not. So our denominator becomes u squared minus 1. And for those who have covered partial fraction integration, this is very familiar to you. If not, I am going to go through it relatively quickly, although I had tons of videos on partial fraction integration. What we're going to do is factor the denominator. So we have u plus 1 times u minus 1 because we have a difference of squares. And now we're going to split this bigger fraction up into 2 smaller fractions. So one with the denominator of u plus 1, the other with the denominator of u minus 1. And we just need to find out what these numerators are after we split them up. So that's kind of the trick. Now, if we imagine bringing these 2 fractions together, merging them and making one big happy fraction again, we need to find a common denominator. So this left term will multiply top and bottom by u minus 1. So we'll have a times u minus 1. And we'll multiply the top and bottom of the other term by u plus 1 to get the common denominator. So it would be b times u plus 1. So when we merge these together to get one big fraction, the numerator becomes a times u minus 1, because to get a common denominator, we got to multiply top and bottom by u minus 1, plus b times u plus 1, because to get the common denominator, we got to multiply the top and bottom by u plus 1. And all of that has to equal 1, because if we merge these 2 fractions together, the numerator is 1. Okay, so we have one equation and a bunch of unknowns, so we shouldn't be able to solve for anything, but the trick is that u can be anything. It could be any real number. So we'll set u equal to something to help us out. And the most obvious is to set u equal to 1, because if we do that, then this left-hand term is 0 if we set u equal to 1. And then we have b times 2 equals 1, so b equals a half. So we got our b. Now to get our a, we'll set u equal to negative 1, because that cancels out this term on the right. And that gives us a times negative 1 minus 1, which is a times negative 2. All of that equals 1. And if we solve for it, a equals negative 1/2. Now, before I move on, some of you might have some red flags going on saying, well, how can you set u equal to 1 or negative 1? Because if we set u equal to 1, in our fraction here, u equal to 1 is undefined. And u equal to negative 1 is also undefined for the other fraction. So that's a problem. But it's not a problem in this equation, the equation for the numerator, because we're not dividing by u plus 1 or u minus 1. So it's okay to plug it in, even though it's not okay in this as a fraction, as in the denominators here. I know it's kind of weird, but it works. Don't hate the player, hate the game. Anyways, we'll substitute a and b, what they are. They're both equal to 1/2. And I just yanked the 1/2 out. I factored it out and pulled it out of the integral. And the negative that's in the a, I kept the negative right there. All right, so at this point, we should be able to integrate this, no problem. We're in familiar territory. The integral of 1 over u is ln of u. We need to slap absolute value signs because u can be negative in the fraction here, but we can't have a negative number in a log. So we have that there. And if we do this integration, we get 1/2, which is along for the ride, times our negative, which is still there, ln of u plus 1, plus ln of u minus 1 with our absolute value signs, plus our friend, the integration constant. And we're pretty much done. We'll just substitute back what u is. U is cos theta. And we're going to invoke a log law where you can merge these two logs together if you're adding or subtracting them. Now this log on the left is negative, so it goes in the denominator. So u, which is cos theta plus 1, goes in the denominator, and the u minus 1, which is cos theta minus 1, is in the numerator, and we're done. But don't go away yet, because we need to prove this result. Is it actually true? Well, I went on desmos.com on the graphing calculator. Now the red curve represents the function that we get when we evaluate the integral. It's this ln function right here that I graphed. And 1 over sine theta should be the derivative of our ln function, because the integral, it's like doing the antiderivative, right? Now, if we look at this function, as theta goes to 0, the slope becomes infinitely large because it gets steeper and steeper and steeper. And also as we approach whatever this value is, maybe it's pi, it goes to positive infinity as well. And then right here at the x-axis, that's as flat as the slope will get. So if we plot 1 over sine theta, this is what 1 over sine theta looks like, which makes total sense because the slope of our function goes to infinity, positive infinity. It gets steeper and steeper, so the slope goes up and up towards infinity. And then also on this side, it goes towards infinity as well. And we have the kind of the flattest or the less steep slope right here at the x-axis right here. And I know that 1 over sine theta is the derivative because in Desmos, you can plot the derivative by writing it like this. And the derivative right here, it just overlaps our 1 over sine theta perfectly, which gives us the derivative.